to know your basic identities in terms of when you see 1 over cosecant, you have to know that the reciprocal of cosecant is fine. What's the reciprocal of cosine? Secant. How do you write tangent in terms of sine and cosine? Sine over cosine. I am not giving you any of those, and if you don't know those reciprocals, you can't get any of these identities to work out. Okay, so make sure you know those. Does everyone understand what you are expected to know? All right. If we look at these, starting with question 10, and we can come back to any that we need to. This is telling us to write it as a function with only x as the argument. The argument is the thing in parentheses. Now, when you have a trig function, can you just distribute it in here? No. So everybody grab your formula sheet. This is the cosine of a minus b. What is the cosine of a minus b formula? You don't have to know those, it's on your formula sheet. 135, what quadrant is that? What's my reference angle? Okay, in quadrant 2, is cosine positive or negative? Negative. And then the cosine of 45? Okay, I can't do cosine x. Sine. In quadrant 2, sine is positive, the sine of 45? Radical 2 over 2. You can leave your answer like this. I don't remember how I wrote it on my key. I might have put them together in a single fraction. You don't have to. This is perfectly acceptable. So 11. You have cosine squared minus sine squared. Look at your formula sheet. Where do you see cosine squared minus sine squared? That's the cosine 2a formula. Okay, my a is just my angle, so 2 times 7x is 14x, and that's all you're doing there. So these, it's just practicing using these identities. All right, number 12. I want you to find sine and cosine of x, but what I gave you is cosine of 2x. Anytime I see a double angle, I always write out a formula. You have 3 options for cosine 2x. You can pick any of them, but probably easiest to pick one that only has a single trig function in it, right? So maybe I do 2 cosine squared x minus 1. I know my cosine 2x is negative 3/4. So how would I solve for cosine? F1. And then what? How do you get rid of a square? If you add a square root, we need plus or minus. How do we know which one it is? If you're between 0 and 90, that tells me that's quadrant 1, and quadrant 1 is cosine positive or negative? Positive. So that's 1 over 8 breaks into 2 radical 2. If you get the radical off the bottom, that's radical 2 over 4. Does everyone understand how we got that? Now we need sine. We have 2 options. We can do the same thing using the other identity, or once you have one of them, what could we set up? We know we're in the first quadrant. We know cosine is adjacent over hypotenuse, so Pythagorean theorem. So the side turns out to be the square root of 14. So sine, opposite over hypotenuse, radical 14 over 4. Okay, I couldn't set up the triangle at the beginning because the information I had was for 2x. I had to get a ratio for angle x before I was able to simplify it. Does that make sense? All right, so 13 is asking me to find sine and cosine of 2x. So when I see that double angle, I first start with my formula. Sine 2x, there is only one formula. 2 sine x cosine x. I gave you cosine x. It's radical 3 over 5. I need sine. So what am I going to have to do in order to get the sine? Set up our triangle. We know cosine is positive and sine is positive, so that's first quadrant. Cosine of x was radical 3 over 5. So a squared plus b squared equals c squared. So square root, but we're in the first quadrant, so it's positive, so this side is radical 22. So then how do we find sine of x? Opposite over half. I'm still using the formula to find my sine 2x, but now I just have to multiply things out. So we have a 2, radical 66 over 25. Check, 66 doesn't break down. That's sine of 2x right there. So that's my final answer. We need cosine 2x as well. We have 3 formula options. You can pick any of them. Which one do you guys want me to use? So sine, opposite over hypotenuse, was radical 22 over 5 squared. So if I square that, that's 22 over 25. And of course, you could use the calculator if you need to. So that would give me 1 minus 44 over 25. So negative. So you can expect to have problems like these on the test. Probably only one like each of them. And in the question, I will probably only ask you to find like either sine of 2x or cosine of 2x. Like I'll probably specify one and not make you do both. But expect to have one question where I'm asking for like sine of 2x and one where I'm asking for a sine of regular x. You know, those two types of questions. Are we okay with these? So really, if you get stuck, just write down your formula, plug in what you have, and see if we can use a triangle to find the rest. All right, problem 14. So we are into all the proofs. What is our strategy with a proof? Box in one side. You have to box in a side so I know what you're working. Which one did you box in here? Now, remember proofs? Is there just one way to do them? No. So if you have something different on your paper, that doesn't mean you're wrong. If you're not sure, ask me. But also make sure on a proof you are showing me enough that I know how you got your answer. Okay, obviously I know I'm working this until I get that for my answer. So if I just do one step and then write down the answer, that's not really enough. You need to make sure everything is shown. Where did you guys start? What are your thoughts? Mm-hmm. And I think that's what you were saying too. Okay, did you guys do anything with the top yet? Okay. So this wasn't the only way to do it, but she recognized that cosine squared minus sine squared is a cosine 2x. All right, so we have cosine 2x. If you multiply by the reciprocal, that's times cosine x over 1. Okay, my final answer, do I want a cosine 2x? No. Look at what we want though. We only want cosines. Look at your formulas for cosine 2x. We have 3 different choices. Which one only involves cosine? 2 cosine squared x minus 1. Then if you distribute your cosine, you get 2 cosine cubed x minus cosine x. Now I saw people work this problem a lot of different ways. Some people worked both sides and factored over here. Some people changed sine squared to 1 minus cosine squared and combined like terms, so lots of different ways to get there. Is that one okay? If I look at 16, which side did you box in? You boxed in the 2 cosine squared minus 1? Oh, sorry, I didn't think anyone asked about 15. All right, which side did you want? Okay, what I want you guys to notice on this is a B, this is a B, that's a 2B. When I see that double angle, that's where I'm starting, and I'm looking for my double angle formulas. What is the sine 2B formula? All right, what happens to my 2's? They cancel. Tangent, what could I change that to? It's all divided by this whole thing. You could think of this as a fraction if you want and flip and multiply. If I flip and multiply, what happens? Signs cancel. So if I just multiply the tops, I get 1 over cosine squared. What is 1 over cosine squared? The reciprocal of cosine. And that is secant squared b that we wanted. Remember, if you're working one and you get stuck, what do? Do you have to erase everything and try the other side? Stop, work the other side, and see if you get to the same point. I might even suggest in this test just having a blank sheet of paper out. If you get stuck on a proof, you don't have to erase everything. You're welcome to go to another sheet of paper and try working it out if you get to a point where you're stuck. All right, 16. I'm assuming we boxed in this side. What did you guys do with the right? Okay, change tangent and sine and cosine. I think that's a good option. Since it's squared, that could be sine squared over cosine squared. Okay. From here, before I could just flip and multiply, we would have to get a common denominator, which you could do. Another strategy that we've talked about when we have a fraction and a fraction, we know we can just multiply top and bottom by the same thing, right? So what would I want to multiply everything by? So if I distribute that, 1 times cosine squared is cosine squared. Minus, when I take sine squared over cosine squared times cosine squared. They drop and we get sine squared. On the bottom, that gives me cosine squared. Plus, here they drop, sine squared. Somebody is with me there? Look at our goal. I only want cosines. I do not want a sine. What could I change sine squared to? On the bottom, what is cosine squared plus sine squared? 1. So then if you distribute your negative, combine like terms, cosine squared plus cosine squared is 2 cosine squared. I have a minus 1 over 1, so we could drop that. All right. What questions do we have? Is this helping at all? So problem 17. Which side would you box in? All right. Okay, on the left, can I just distribute my sign? No, that's why we have all of those identities. So go to your flip chart, sum and difference formulas. What is sine of A minus B? So this involves us knowing sine and cosine at 270. You can think about hand trick or your unit circle. So 0.0, negative 1. Sine is the y, so sine of 270 is negative 1 times cosine theta. Cosine is the x, so that's 0. So negative 1 times cosine is negative cosine minus 0. It's just negative cosine. All right, problem 18. Which side did you box in? This one is a little bit ugly. If we want to add or subtract fractions, what do we have to have? Right, so I'm going to have to take the first one times 1 plus cosine theta on top and bottom. This one by 1 minus cosine theta. So hopefully you're kind of seeing some things. You'll have some problems where you have to use like the sum and difference formulas in your proofs. Probably have something with getting a common denominator because we've done that several times. So if I multiply this out, I get sine theta, cosine theta. Can I go ahead and write it as one big fraction? Over here, if I distribute it, sine theta, cosine theta, and sine theta, cosine squared. On the bottom, by FOIL, I get 1 minus cosine squared theta. What do I do with my negative? Then sine, cosine, minus sine, cosine, those cancel out. So I'm left with sine, cosine squared. On the bottom, what is 1 minus cosine squared? All right, look at our goal, because it may not be obvious where to go next here. But if I look at my goal, I want things multiplied together. So if I'm going to turn this into a multiplication problem, what do I have to do? So we have a couple different options. The easiest one though, could we just factor? On the top, they both have a sign. So if we take out a sine theta, that leaves us with 1 plus cosine squared theta. That's looking good because I want 1 plus cosine squared. What happens with my sines? I can cancel one of them. So I have 1 plus cosine squared over sine squared, but the reciprocal of sine is? So that is my cosecant times 1 plus cosine squared. Okay, so don't forget to look at your goal so you kind of know what to do next. That will guide you a little bit. Problem 19. What do you notice if you look at the angles? Theta, 2 theta, and theta. If you have a double angle, you need to start there. What is sine 2 theta? Looking at my goal, I only want cosines, so what could I change tangent to? What happens? Cosine's on top and bottom, so it cancels. So 2 times sine is 2 sine squared theta. We are close, but look at our goal. I don't want sine squared. I want cosine squared. What can I change sine squared to? So then if we distribute, we get 2 minus 2 cosine squared theta. So keep your goal in mind. My goal only had cosines, so I knew I had to replace the sine. All right, problem 20. The left-hand side, they both have double angles, so I would start there. 2, cosine 2a. There are 3 formulas that I could pick from. Look at your goal to help you guide, or to help guide you. I want a cosine, or a cotangent and a tangent. That means I need both cosines and sines. So pick the formula that has both of them. So that's cosine squared minus sine squared. Sine 2a, we only have one option. 2 sine a cosine a. What happened? Drop off my 2, top and bottom. Okay, I have 2 terms on top and only 1 on the bottom, so we could break this fraction apart. If I do that, what reduces in the first fraction? Take a cosine off top and bottom. What about the second one? So we have a cosine over sine minus a sine over cosine. But cosine over sine is tangent A, and sine over cosine. I think there must be like a box nest outside my window because I get a lot of them in here. All right. Are we okay with that one? All right, 21. Start with whatever side we can use an identity on. So we've had several that had double angles. We started with those. This one, what do we see in it? It's not a double angle, but it's a, yeah. So let's do the cosine difference formula. So, cosine difference, we do cosine of the first, cosine of the second, cosine of the first, sine of the second. At this point, it's very similar to the last question. I have two terms on top, one on the bottom. So if I put each thing over the denominator, what happens in the first one? Cosine A drops. What is cosine over sine? Right, in this one, my sines drop. What is sine A over cosine A? And that's what we were looking for, just in a different order. Alright, so I told you on the test that we would have these, but I would probably only ask you to find one of the other angles, not all of them. So if I said find cosine 2a, how many formula choices do we have? 3. I gave you cosine A. So which of the 3 do you think you would pick?
2 cosine squared A equals 1.
Alright, so then I can plug in. My cosine of A was negative 5/8 squared minus 1. Square, multiply by 2. So if I gave you this, again I gave you a cosine 2x, so we're looking at those double angle formulas. If all I'm looking for is sine x, which formula do you think you would work with? Okay. So we can plug in what we know. The cosine of 2x was 3/4. And then I could solve for sine. So if I subtract 1, divide by 2. To get rid of a square, and with that, plus and minus, how do I know if it's plus or minus? If I'm between 90 and 180, that is quadrant. And in quadrant 2, sine is positive. 8 would break into 2 radical 2. So get the radical off the bottom. And get radical 2 over 4. So really they're kind of easier if you're only finding one thing. You don't really have the need to set up a triangle now to find the other sides because I'm not asking you to evaluate any others. All right. Is this okay? What else do we want? All right, so if I'm asking for sine 2x, what's my formula? So I'm just using that formula, but the problem is I don't know sine x. I know cosine. How do I get my sine? Triangle. How do I know which quadrant? Cosine's negative, so I know that's either 2 or 3, but sine is positive, so that's quadrant 2. Okay, cosine adjacent over hypotenuse. So then how do we find our third side? Mm-hmm. Is there a bee flying around me? Why do I have so many bees coming in my classroom? I swear. Hopefully it'll fly back out. So we have negative 5 squared plus b squared equals 8 squared. Okay, square root, how do I know if it's positive or negative? Yep, in quadrant 2, that would be a positive, it's going up. And I can't break down that radical. So sine opposite over hypotenuse would just be radical 39 over 8. And so then we just multiply together. So multiply the tops, multiply the bottoms, and reduce. You should get negative 5 radical 39 over 32. I have a fly swatter. I've shooed a few out today, but I don't know where that one went.
Maybe it smells nasty.
It must be. I mean, they've even checked outside my windows to see if there's something, because I get so many bees in here, and they can't figure out where they're coming from. I think they are inside the AC units, actually. All right. What else that a lot of people got stuck on? It was don't worry about it. I'm sure it'll be fine. Open the door and hope he flies out and someone else's problem now. All right, which side would you box in? All right. Okay. When we had this one on our quiz, a lot of you, is he gone? Yeah. So much for fresh air, guys. It's not worth it. Okay. A lot of you try to get a common denominator here, which is usually a solid option, but it kind of made this problem significantly harder when we tried it. So what else could we do? Sines and cosines. Secant is 1 over cosine. Cosecant is 1 over sine. How do we divide fractions? Okay, so we have cosine times cosine, which would give us cosine squared theta. I have sine times sine, which gives us, and what is cosine squared plus sine squared? 1. Okay, so don't forget, you can work these two things separately. Just go to your sines and cosines. If you get a common denominator, you'll get there eventually. You just still have to change the sines and cosines and simplify. What else? Do you guys want a proof to try on your own? Box in. The right. I heard the left. That's also okay. You know, you can do either one, or you might have to work both and see if you get to the same point. If you box this one in, what did you do on the left? You have to FOIL. So we get sine squared x plus sine x cosine x plus sine x cosine x What's cosine squared x? What'd you do from here?
Adding. What else you could add?
Okay, so if you add those two, you get 2 sine x cosine x. Did you recognize anything about sine squared x plus cosine squared x?
It's your-
Look at your goal. So if I get here, I'm thinking, what comes next? I know I want a sine of 2x, but what's the sine of 2x formula? Isn't it just 2 sine x cosine x? So that's the identity. And we got it. All right, probably the last one we'll get through today. What would you do here? We have cosine of a plus b. So I go to our formula sheet. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. Plus, over here, cosine of a minus b. So we'll go to my formula sheet, cosine of the first, cosine of the second, plus sine of the first, sine of the second. Okay, cosine of 90. If you need to, you can do unit circle. You can think about your hand trick. Cosine we know is the square root of the bottom. What's cosine of 90? 0. What's the sine of 90? Cosine of 90 is 0. So this is just a 0, that's gone, so I have a negative sine x plus sine x, which is